This poster presents long-term deformation at Erebus Volcano in Antarctica. My name is Monica Appentine at the University of Alaska Fairbanks. This is work with Phil Kyle, Rick Astor, Terry Wilson, and Julian Chaput. This first figure shows a map of Ross Island with a zoom into the summit plateau region and the current crater of Erebus Volcano shown over here. The black dots show the continuous GPS network. The white dots are campaign stations. The red vectors are long-term, so 20-year velocity vectors in the horizontal. The orange vectors are the vertical component. Antarctic plate motion has been removed. You can see that Ross Island overall is subsiding, maybe more in the center than at the edges. The horizontal motions are a little less conclusive. The data that are available reach back into the late 90s. In the beginning, first campaign observations, which later transitioned into continuous stations on the flanks and the summit plateau of Erebus Volcano. We right now have 7 continuous stations that are deployed, some of which replace older deployments. The time series of those are tied, as shown here for Hooper Shoulder and the north component. We spread out the time series in this plot for clarity, but you can see that several stations show some transient motion here as Nausea Knob shows northward, southward, and then recently again northward motion. These transient episodes are consistent throughout the network and indicate inflation, deflation, and then inflation again. If we plot the vectors for these time periods, we can see up until 2004 in the horizontal components, clear outward motion away from the from a magmatic source right here near the crater. From 2004 to 2011, inward motion, and recently again outward motion. Scale bar is about 5 millimeters a year here. The vertical components are less conclusive, which indicates that a single simple analytical source is likely not going to match the data. We have a preliminary model for this on our poster. The source is between 1 to 3 kilometers depth, right around here near the modern crater. However, we still have to remove GIA and Ross Island isostatic adjustment signals to better fit the verticals.